So the next thing so normally I would teach this tomorrow, but again, I'm not really supposed to. So today is 421, and the next thing on the to-do list is not factoring, but rather solving quadratic equations. And there are tons of different ways to solve quadratic equations. Lots. The one we're going to do specifically in this class right now is we're going to solve quadratic equations. I'm going to put this in parentheses by factoring. There are other methods like the quadratic formula, completing the square, graphing. There's all sorts of things we could do. But this being perfectly related to what you're learning right now, this is a perfect logical place to just pack this in. So you won't feel a lot of burn here today. So take a look at something like this. That is not a quadratic equation. That is called a quadratic expression. The moment you add this, it becomes an equation. You know this, that when you put an equal sign in something, like 2 plus 2 is an expression. 2 plus 2 equals 4 is an equation. If you put an equal sign in something, then you make it an equation. So what changes now is that I have a full verb in there. I've got all this stuff equal to 0. And trying to solve this, I'm not going to give you the long version of this lesson today. Just trying to solve this in your head would be really hard. Most people can find one of them, but there are two answers to quadratic equations, and you can tell that because the exponent is a 2. And so most people, math people, could reason through this and go, oh, I figured out what X is. And it's like, well, that's really cool. But there's another answer that's a little bit more difficult to find. So the way we find it is we take this left side and we factor it. And this is exactly what you're quizzing on today. So this is kind of a good multi-purpose thing. It's like a review plus something new. So if I factored this left side down, I would build my shells. I would put in my X's like this. What are my signs going to be? One of each for sure, because they multiply to make -12. And what numbers are we thinking of? Definitely in this case, though, 6 and 2, because we want, and I'm not going to go into great depth on how to factor that. We've been practicing that for a week, but this is the combination that will work. Okay. So if you tested this with your purple and green, it does multiply and add correctly. Okay. I hope we agree. So this is where the newness of today's lesson starts, is it comes down to basic logic. I have two things here, a red thing and a yellow thing. And what I'm going to ask you to agree with me on is just some probably fourth grade logic. So don't read too much into what I'm about to say. You would agree that if I multiply the red box by the yellow box and I get an answer of 0, when you multiply two things and get 0, what has to be true? Think about what you're saying. Don't just say words. Think about this. If I told you in my head right now that I had a multiplication problem, something times something, and the answer was 0, what could you tell me? One of my numbers has to be 0, right? That's like irrefutable. The only way to get 0 is if one of your numbers is a 0. So let's talk about the red box. Maybe the red box is the one that equals 0, right? Maybe. What would you have to put in place of that X right there to make the red box equal 0? And we have one of our two solutions. So -2 would solve this equation. It would actually make the equation true. What number makes the yellow box equal 0? And those are your solutions to the quadratic equation. It means if you went back up into the original equation and you turned all of these green X's into, say, 6, the equation would actually be solved. What's 6 squared? 36 minus, what's 4 times 6? 24 minus 12. What's 36 minus 24? 12. 12 minus 12 equals 0, right? So to solve a quadratic equation is basically just one extra step. You already know how to do the factoring. Let's practice again. This should be easy factoring. Build your shells like this. What are the signs going to be? One of each. And what numbers are we thinking of that will multiply to make 14, but add correctly? Bless you. 7 and 2, for sure. If I put a 7 and a 2, of course, those multiply to make -14, right? What makes this factor equal 0? -7. I mean, just think about it. If you put -7 right where I just turned that X red, what's -7 plus 7? We did it. We made a zero. It doesn't matter what the other one is if you can make one of them equal zero. Let's talk about the other one. I'll underline him in yellow. What makes him equal zero? Just 2, right? And we agree again because 2 minus 2 equals 0. So you basically take each factor and say, how can I make u equal 0? How can I make u equal 0? Let's go again. Okay. If you can factor, this is light work. Easy peasy. Right? So again, we have the new guy today. The equal 0 has entered the arena. So we're going to say, okay, first thing my teacher told me is I better break this down. Okay, I got equals 0, so let's break this down using our shells. Always copy your equal 0. Those of you taking notes, thank you. You're going to write that down. Always keep your equal 0 intact as you go. All right, that's kind of a consistency thing. And what are my signs going to be? Both pluses, and what numbers? You probably already have it figured out while I was talking. 8 and 2 for sure, right? Because, and again, just in case you're a little confused, it's what we've been doing for 2 weeks. Those multiply to make 2x, those add or multiply to make 8x, right? 2x, you get the idea. It's all you've been doing in class. So what makes the first factor, this thing, I'm going to underline it, is called, it's a noun. It's called a factor. What makes that factor go to 0? It's not a -8, it's a -8. The number -8, if you put it in, kills that factor. What number could you put in place of x to make this factor equal 0? And there are your solutions to that particular quadratic equation. Each of those numbers, you could change x into either of those numbers and they'd both wash out. All of this stuff that I'm circling would wash out to equal 0. Okay, let's go again. And again, this is a problem you might see on the quiz today. This is not, right? It's this tiny little new addition. Add the 0, easy peasy. Let's factor. Build your shells. What are the signs? I guess 2 minuses, right? Because they have to multiply to make 32, which is positive, but add to make negative. So that's the only way to make it work. What numbers already have come to your mind? Wow. 4 and 8, that shouldn't take that long. Okay. So if we have a 4 and an 8, they multiply to make 32. And then my purple green will add to make -12. What makes this factor die? +4, not a plus, just a 4. +4, just a number, not a verb, just a number. What makes this factor die? 8. Okay. So there's one more little scaled up level to this, and it looks like this. Again, assuming you've not been absent for the last 2 weeks, this is not a big deal for you. You're fine. You're going to take this and you're going to factor it down using shells. What's going to go in the starts of my shells? 2x and 1x. And what are the signs going to be? Minus and minus. And the numbers we're looking for are 5 here and 3 here. Okay, and you can check it. It works. These make -10x. These make -3x. There's your -13x. You'll notice there's something a little bit new going on here, and there's a new number, and it's right here. I'll point to it with a red arrow. Big brain question. What makes that red thing that I underlined equal 0? Let me ask you a question. If I scribbled out this too, what would make this red thing equal 0? X equals 3 is the answer. You just have to divide it by 2 because there's a 2 in front of the X. Okay, that's all there is. That's the only difference. What makes this yellow one equal 0? 5. Yep. Okay, let's go again. And I'm just going to speed factor for you here because I don't want to spend our time while we search for this and that. We know the shells look like this and this. What are the signs going to be? One of each for sure, right? And we're going to want a 4 and a 2. If you put a 4 here and a 2 here, you get 4x, 6x, and you want the minus on the heavy and the plus on the light. Okay. So again, I know you could do that. It might take you a little bit longer than me, but that's fine. It doesn't matter. And so what makes this red one equal 0? That. Nice job. -4, but you have to divide it by the 3 that's in the front. And what makes this yellow one equal 0? 2. These last two examples, I'm not even going to ask you to factor them, okay? I'm just going to write down what we call the factored form. That sounds nice. The heat or whatever went off. Can you hear how quiet it is? Oh, that's lovely. So let's say I gave you a factoring problem and you came up with like 4x plus 3 times 2x minus 5. All right, so all the factoring has been done and you get to here. I hope you're paying attention. What makes this red thing equal 0? X equals what?
Equals.
It would be -3, right? But I got to divide by the 4 that's in front. What makes this yellow one equal 0? It would be x equals 5, right?
5 halves.
But I got to divide it by 2, 5 halves. One more. So let's say I gave you a factoring problem and you worked really, really hard. And at the end of it, you had 7x minus 11 times 3x plus 8. That's a hard factoring problem right there, right? But you did it. You made it this far and you're like, man, I'm the world's best factorer. Now it's time to cash it in. What makes this equal 0? Positive 11 over 7. See how simple that is? And what makes this equal 0? -8, but divided by 3. So that's what you'll be working on after you turn in the quiz. So sorry to do that to you right before a quiz, but we do need to pack as much in now as we can. Clock's ticking. So quiz, 12 questions. When you're done, turn it in and I'll swap you and I'll give you assignment number 52. Got it?